So, hello everybody. Can you hear me? Do we have any confirm? Awesome, awesome. Okay, let's go and let's see what do we have for you guys. And I hope it's gonna be a great meeting that we can hold together. So, let's start with our company. Let's start to talk about our company. What do we have on our side? So, as you know, actually, thanks for joining to the meeting. My name is Said Fawadi, as I actually as a founder of Seminode. If I want to talk about just a brief background of myself, I have about 15 years or even more than 15 years in network industry, like a network security architect, and even I spent years of designing and running large networks. So before Ehsan gets into the hands-on part, I'll take about 2 minutes, and explain who we are and why we run this session and what can you get after this meeting, actually. So as you know, SME Academy is a live instructor-led, actually, IT training, not a recorded playbook, not just, for example, like a small, or let's say, very, very brief meeting, for example, brief actually recorded meeting. We are going to be here to have a real instructor, real cohort, and real labs. Everyone who teach you here, it's going to be a real engineer. So what you learn is what you actually do on the job. So this topic, network automation with Ansible and AI, is a good example that's you can achieve. It's practical, and it's where the work is moving right now. So, Sonny, if you don't mind, please go to the next slide. Oh, okay, awesome, thank you. So, let's talk about the slide number 2. We build our training around 4 tracks: networking, security, cloud, and DevOps. They are not separated slides. A network engineer today writes code, a security team runs thing in a cloud, and the DevOps pipeline actually touch all of it at the same time. So what Ehsan is about to show you sites right where networking meets DevOps. For example, you take solid networking knowledge and you add automation on top. That's combination is what employer are paying for. Whatever track you start in the goal in the same, get your job ready, and for example, not just certification on paper. We are not here just to give you a certification or, for example, help you to get your certification. We are here to help you get, or even actually have a better job along with certificate. If you want to have a certificate of network automation like CCNA, CCIE automation, that help you to have better job and better understanding of the skill that you achieve. So that's why I'm gonna actually talk about slide number 3. Efsani, if you don't mind, actually go to slide number 3. So this thing, first class or live, for example, with a real instructor, you can actually interrupt and ask question. Feel free to ask any question if you want. Second, you practice in a real lab environment, for example, you break things, you fix them. We are not just saying that, okay, how to, for example, do this one and done. No, you are able to do anything that you want in a real lab environment. You can break them, you can fix them, you can ask your instructor how to help you, for example, to fix this one, even know about how to do it in a real scenario, in a real job. That's why we are not just saying that, okay, here's the, for example, laboratory and do your job and you learn it and done. No, we teach you all the time to get your real scenario. So every course maps to the industry certification. So your effort counts toward something that the market recognizes. So honestly, these days, even in Europe, actually, people are asking me to, for example, how can I actually learn? How can I actually study? For example, automation, Bash script, Ansible, Python, because Every job description these days exactly mention you have to learn, you have to actually know about automation skill, because these days people try to automation everything, not just, for example, configure and leave it as is. They want to have even agents, even, for example, LLM in their environment to build everything better than before. So, by the way, we have a sister company, Seminode Labs, that's help you to have to actually go with workbooks like a lab kit that you can keep at the same time with Seminode Academy. Absolutely, that's another side of actually studying everything, not just automation, not just, for example, Python, Ansible, Git, or something like that. Even for, let's say, CCIE Enterprise, CCIE Security, CCIE Data Center, DevOps, Cloud, a lot of things that we will actually unveil them soon. This setup actually, let's hands over to Ehsan. I believe Ehsan can actually go ahead, and at the end of the day, at the end of this meeting, I'm gonna be here again and tell you what do we have after Ehsan finish. Ehsan, can you continue?
Hello, everyone, and a very warm welcome. Thank you for taking an hour out of your day to be here. My name is Ehsan Momeni. I work as a senior network automation engineer and DevOps consultant. I spend my working days between two worlds, network operations teams on one side and automation code, for example, Ansible repositories, Python repositories, CI pipelines, and now AI-assisted tooling on the other. Over the years, I have helped teams take automation from a script on someone's laptop to a reviewed version-controlled workflow that operations can actually trust. So let's start. So from playbooks to production, Ansible, AI, and network automation, we will build a structured way to bring AI. 5 building blocks at the bottom of the slide: inventories, roles, Jinja 2 templates, compliance checks, and assisted review. These 5 chips are, in one line, the whole agenda of the next hour. Let me break those 5 blocks into the concrete topics we will cover. Here is the full menu, and I read it quickly so you want to know what is coming for you. First, project structure. How a real network automation repository should look. Second, inventory, variables, and data modeling. In my opinion, the most underrated topic in Ansible. And third, clean, idempotent playbook design and reusable roles for repeatable network work. Then we have Jinja 2 templates for multi-vendor configuration. We have one data model, many platforms. After that, check mode, diff mode, and drift review, the safety net. And finally, AI-assisted tooling and drafting, explanation, and review, where AI genuinely helps and where it absolutely must not replace you. To make sure we are all starting from the same place, let me state the assumptions I am making about you and your network. I'm assuming 5 things today. 1, you already know basic Ansible syntax. I will not explain what a task is. 2, your network is mixed. For example, Cisco, Juniper, Arista, or something similar. 3, device access already works over SSH or HTTPS. And 4, your playbooks, roles, and inventory live in source control in Git. And 5, the important one, secrets are stored outside plain text repositories in something like Ansible Vault. Here is how the hour is laid out, so you always know where we are. The slide is a table with our timeline, so let me walk it top to the bottom. Let's start with the problem that motivates all of this, and I suspect many of you will recognize it. We want to go through to the real problem. Lab automation often becomes production automation by accident. Let me be honest, nobody plans this. It just happens. And when it happens, it looks like this slide. One big playbook grows too fast, It started as a quick test, and now it is 400 lines. Vendor logic gets copied between tasks. The same Cisco commands pasted in 3 places. Dry run output arrives too late. So the first real feedback you get is the change window itself. On the right side, you have device facts and intent data get mixed together. So nobody knows what is desired state and what is just observed state. Reviewers can't predict what the change will actually do. And the newest one, AI output, gets trusted before it's tested. So now why this is important? Because every one of these 6 pain points has a structural fix. And that is exactly what the rest of this stack is. So let me show you the target architecture we are aiming for, the fix in one picture. This is the whole webinar in one diagram. We have 5 steps left to right. Step 1, a source of truth, somewhere authoritative that says what the network should look like. And we have step 2, inventory and variables, that truth expressed as a structured data. And we have step 3, roles and templates, the machinery that turns data into device configuration. And after that, in step 4, we have check mode and diff. We look at what would change before anything changes. And step 5, human review and controlled apply. AI can assist at each review point, but it doesn't replace any gate. That sentence is the philosophy of this entire session. AI is a reviewer's assistant, never the approver. Everything starts with structure on disk. So here is what a production-grade project tree looks like. Here is a project tree I recommend, and the line at the bottom says it all. Structure is a safety control. At the top, we have Ansible configuration. That is a project behavior pinned in the repo. And after that, we have requirements.yaml file, our collection dependencies, versioned like any other dependency manifest. And after that, we have our inventories with lab and production separated. This separation is not cosmetic. Pay attention to this. It is what makes test it in lab first a real, enforceable habit instead of a good intention. After that, we have our playbooks, small entry points like validate the YAML and configure interfaces of YAML files. After that, we have our roles, the reusable machinery. For example, interface baseline, NTP client, and also somehow logging baseline. After that, we will have our templates, tests, and docs. In real-world projects, this usually means when a new engineer joins, they can find anything in 30 seconds, okay? And when something breaks at 2 a.m., so can you. Let's zoom into the first file in that tree, I mean Ansible CFG file. This is a small file that quietly prevents big accidents. Let me highlight the lines that matter for us. After that, we have inventory defaults to inventories/lab, okay? So if anyone runs a playbook without thinking, it hits the lab, not production. Safe by default. After that, we have our roles path and collections path that keeps everything inside the project. We will have our acidic callback. YAML file gives you the readable output during reviews. Also, we will have host key checking that is set to true. Yes, it is slightly less convenient. And yes, you want it on in production. Also, we have our retry files enabled that is set to false. That keeps the repo clean. And in the inventory section, we enable the plugins we actually use. For example, YAML INI constructed and the Netbox inventory plugin, which we'll meet again in a few minutes. Next to its requirements at YAML, our dependency manifest. You must treat Ansible collections exactly like software dependencies, declared, versioned, and installed from a file. In requirements.yaml file, we list what this project needs. For example, Cisco iOS, Cisco NXOS, Arista EOS, and anything you use. Junos, Ansible.NET Common for the shared networking plumbing, and Netbox for dynamic inventory. We will have one command at the bottom that is Ansible Galaxy related to installing requirements.yaml, and any engineer or any CI runner gets the identical environment. What is the key point here? Let me know. works on my machine stops being an excuse. Now, how does Ansible actually talk to network devices? That is the connection model we want to talk about in the next slide. Network automation connects differently from server automation, and this slide is the standard shape. In group vars for all devices, we have Ansible collection that is set to net common network CLI, that the network CLI transport. We will have the username and password come from vault variables. You can see the vault NetOps user and vault NetOps password references. So no credentials ever sit in plain text. This is so important, and you must pay attention to this. And we will have Ansible become that is set to true with see the key points on the right, become method set to enable, which is how privilege escalation works on network gear. Two more things on the right worth saying out loud. Network modules often run on the control node, not on the device. That is normal. Devices rarely run Python, and platform setting belong in inventory data, not hard-coded inside playbook. In real-world projects, this usually means connection problems become data problems, and data problems are visible and reviewable. That phrase, inventory data, deserves its own section because inventory is where good automation is won or lost. Here is a mind shift. Inventory is not a host list. Inventory is a data model. It answers much more than what hosts exist, which devices are in scope for this playbook, this change, this site, which platform does each device use, because that decides modules and templates, which site, role, and lifecycle state applies. Is this box production or being decommissioned? What connection settings are needed, and which values are shared, which are platform specific, and which are host specific? Now, why is this important? Let me know your idea about the importance of this section in the chat, but let me clear, because every single one of these questions will be asked by a playbook, a template, or a reviewer. If inventory answers them clearly, everything downstream gets simpler. Let's see the simplest possible version in inventory, that is static inventory. This is a static YAML inventory, small, honest, and perfect for a lab. We have a group called Edge with two hosts, Edge R1 and Edge R2. The number one running Cisco iOS and the second one running Arista iOS. Notice that Ansible Network OS is declared per host. That one variable is what later selects the right modules and the right template per platform. And notice the caption, good for labs, limited for changing production data. The moment devices come and go weekly, hand editing YAML becomes the weakest link. We will fix that with dynamic inventory in a moment. But first, even in a static file, how you shape your groups matters a lot. So in the next one, we will talk about group design. Here is my favorite line of the whole deck at the bottom. Group by intent. Pay attention. Again, group by intent, not by someone's spreadsheet tab. Look at the hierarchy. We have platform groups that is set to platform Cisco iOS, platform Arista EOS, Junos, and also our site groups, site Toronto, site Vancouver, role groups. We have our role edge, role distribution. Three clean dimensions, what it is, where it is, and what job it does. Any real change you will ever make targets some combination of these. All edge routers in Toronto on Cisco iOS becomes a simple group intersection instead of a hand-maintained list. Once groups are clean, the next question is which variable lives in which file? This is meaning by ownership. This table answers the question, where do I put this variable? And what is your strategy if you're using Ansible in your companies, in your projects? What is your strategy for this? The answer is wherever its owner lives. Read it row by row. We have three group vars, one for all.yaml, one for platform Cisco iOS, and one for site Toronto. The first one, that is all.yaml file, is owned by the automation team. Global things like naming rules. The second one, that is specific to platforms, is owned by the platform owner. For example, command style, platform quirks. And the third one, we have the site-specific parts that belongs to the site owner. For example, we have NTP, DNS, syslack servers for that site. After all, we have host variables. For example, here we have edge R1 YAML file that belongs to the device owner. For example, the loopback address or the uplinks. And the vault file, the somehow important part for security, is owned by security. That is just credentials only. The key point here is accountability. Every value in the project has exactly one natural home and one accountable owner. So don't forget, again, every value in the project has exactly one natural home and one accountable owner. When a value changes, you know whose review you need. And what do these variables actually look like? Here is intent data, desired state as data. This is intent data for one interface, and I want you to notice what is here and what is not. At the first part, let's see what is here. We have an interface list. We have the name, Gigabit Ethernet 01. We have description. We have IPv4 addresses and subnet mask, and we have service policy for input and output. But what is not here? A single line of vendor syntax. We don't have interface Gigabit Ethernet 0/1 as a command. We don't have no shutdown as a command. The caption says it precisely. Intent data describes the desired state. It doesn't copy vendor syntax. Now, let's see why this part is important for us. I mean, intent data. Because this exact same block can render into Cisco iOS, Arista EOS, or Junos. The intent stays stable while the vendors vary. That separation is what makes multi-vendor automation manageable. Static files are fine until the data starts changing weekly. This is when you go dynamic. You need to use dynamic inventory when device data changes often, or when it already lives in a system of record. The usual sources are on this slide. For example, here we have Netbox, which is the de facto standard in network automation. We have cloud inventory sources. We have our CMDB. We have our IPAM, any IP-backed inventory, plus constructed groups, which build groups automatically from metadata. And you need to note the warning at the bottom. The Ansible documentation recommends inventory plugins over the older inventory scripts. So if you still have a homegrown inventory script from years ago, plugins are the supported path forward, and you need to use the plugins. Here is what a Netbox inventory plugin looks like in practice. It is surprisingly small. Let's check it out. This is a whole file. We have our inventories, production, and netbox.yaml file. This is our YAML file for Netbox. We use the plugin NB_inventory that is related to Netbox. We have our API endpoint, and look at the token line. It is a lookup from the environment variable, Netbox token that you see in this slide. The token is not in the file, so the file is safe to commit. After that, we will have validate certs that is set to true. Keep TLS honest, and after that, we have our group by device roles, sites, and platforms. So Netbox automatically produces exactly the role, the site, and platform groups we designed by hand 2 slides ago. And compose a set Ansible host from the device's primary IP in Netbox. In real-world projects, this usually means Netbox becomes the single source of truth, and your inventory maintains itself. Whichever inventory you use, static or dynamic, test the inventory itself before you run any playbook. This is the topic of our next slide. We have 3 commands here, and they cost you 30 seconds before every serious changes. We have different switches for Ansible inventory and also Ansible all. We use dash graph that shows the full group 3 in our inventory. Also, we can use the dash host switch by maintaining and mentioning the desired host. For example, here we have age R1 that shows every variable that host will actually receive. And after all merging and Ansible all -I inventory that you see, the third command shows exactly which hosts match your pattern. While they run, ask the 3 review questions and write, is the target set correct? Are variables coming from the expected source? And are the platform groups correct? These are the 3 questions that is so important in the inventory we want to test before running the playbook. The key point here is most automation accidents are actually inventory accidents. This is the cheapest insurance you will ever buy. With data in good shape, we can talk about the code that consumes it, that we call it playbook. One sentence defines a good network playbook. Maybe you know it, maybe you don't know it, but it should be small enough to review. Not clever enough to impress, but small enough to review. Concretely, that means the 6 properties on this slide. 1 operational purpose per playbook. Our playbook must have 1 operational purpose for each playbook. We need to have a clear target pattern, no mystery about which hosts. It must be clear, and we need to use explicit tags. We need to variables validated early so bad data fails fast. We need to use roles that do the repeatable work, and dangerous actions are isolated. For example, reload, replace, and erase live in their own quarantined space. Ask yourself, can a colleague read this playbook end-to-end in 2 minutes and predict what it will do? If it is yes, it is production grade. And if your answer to this important question is no, split it. You need to pay attention to this question after you write playbook. It must be small enough to review. The next property deserves its own slide because in networking, it is not automatic. It is idempotence. Idempotency is such an important part, an amazing part that we have in Ansible. Idempotence means repeated runs don't create extra change. Run it once, run it 5 times, same end state, and runs 2 through 5 report no change. On network devices, this needs deliberate care. So here are the practical checks. Prefer resource modules where available. They understand device state natively. As I mentioned in the previous slides, you need to, and Ansible documentation, prefer that using resource modules where available. Express intended state, not send this command again. You need to parse existing config before replacing whole blocks. You need to treat command modules as read-only unless there is truly no alternative, and check the change status during dry runs. If a dry run says changed every single time, something is wrong with the logic, not with the device. Why does this matter so much? Why do we talk about idempotency and we just want to see the no change and after running so many times? Because idempotence is what makes automation rerunnable after a failure. And rerunnable is what makes it safe. Let me show you a playbook skeleton that bakes these slides and ideas in. This is a complete production-shaped playbook, and it fits on one slide and somehow a short part of the whole playbook. Let me read it with you. We have at the first part the name, configure interface baseline. After that, we have hosts as edge, that is a group declared visibly. And after that, we have gather facts that is set to false. Network devices don't need the default fact gathering, and it saves time. And we somehow use serial 1. This is the rollout throttle, 1 device at a time. If device 1 goes wrong, device 2 is untouched. So if you want to fail fast, you need to use serial 1. And then we have pre-tasks and assert that interfaces is defined and not empty. So if the data is missing, the playbook fails in the first 3 seconds before touching anything. And then the actual work is a single line, the interface baseline role with the interfaces tag. The playbook is just the frame. The machinery of the code, the playbook, the script lives in the role. This is the pattern. Validate first, roll out slowly, and delegates to roles. Notice how short that was. Targeting flags at runtime gives you even finer control. So let's talk about targeting controls. Here is the same playbook at runtime with the safety flags spelled out. We can see here that we use switches -- limit, -- tags, we use serial controls, we use check mode validates before apply. By using -- limit, for example, here we limit that to edge R1, and we narrows the blast radius, one device instead of a fleet. And after that, we can use the -- tags that is narrowing the task scope. Serial, as we mentioned earlier in the previous slide, inside the playbook, controls rollout pace, and check mode validates before any apply. In real-world projects, this usually means your first production run of anything is limit one device, tags one scope, check mode on. Then you widen deliberately step by step. So you need to limit the one device, tags one scope, and after that you can compromise it. I keep saying roles do the work. So let's open up roles properly. Name roles after network outcomes, okay? The things operations actually ask for. Look at the example here. We have interface baseline role, we have NTP client, we have logging baseline, we have SNMP baseline, and any other things that you see in the slide or in your mind. Each one is a complete self-contained operational promise. But here we have a warning at the bottom that matters a lot. That is related to naming convention, that is related to your runbooks. Avoid roles named after tickets or one-off projects. A role called CHG 0042, I mean change number 42, or Phoenix project tells the next engineer nothing. Outcome names are self-documenting and reusable. Inside each role, I recommend one standard layout. Let's see it. This is the anatomy of the interface baseline role, for example. We have the defaults, we have the tasks, we have the templates, we have the meta, and also we have the markdown file, the README file for each role, okay? We have defaults / main.yaml file, the tunable knobs, tasks split into main, validate, render, and deploy. And that split is the important part. You will see why in a moment, okay? Templates, for example, here, one Jinja2 file for platform. For example, iOS.j2 file or Junos.j2 file, or maybe 40os.j2 file. Meta / argument specs, the YAML file that is running the specs, the roles input contract, and the README file, because roles get reused by people who were not in this webinar. The key point here is the task split. We see here validate, we see render, we see deploy, that are separate stages. So you can run any stage alone. Two of those files confuse people constantly: defaults versus vars. And we have 30 seconds to clear it up, okay? Simple rule, straight from the slide, defaults are overridable. Role vars should be rare, and in defaults.main YAML file, we put the knobs users may turn, for example, interface baseline enabled, the render directory, the backup on or off, and the lowest precedence. Any inventory value can override them. In vars main.yaml file, we put near constant out of the role itself, like supported platforms, for example, Cisco iOS, for example, EOS, Junos, 40os, and it is high precedence, hard to override, which is exactly right for facts that define the role. If you are ever unsure, put it in defaults. And when in doubt, be overridable. There's no problem for this. Now, How does a role protect itself from bad input? Let me show you how we protect from bad input. We have argument validation strategy for these parts. This is the meta, the argument specs.yaml file. The roles contract with the outside world. It declares interfaces is a list. It is required, and its elements are dictionaries. Interface baseline enabled is a Boolean, true or false, defaulting to true. If a caller passes garbage or forgets interfaces entirely, Ansible rejects the run before a single task executes. The caption says it well. Validate the contract before rendering config. Cheap to write, and it turns silent data bugs into loud early failures, the good kind of failure. With the contract validated, the role run its pipeline. Validate, render, and after that, deploy. So let's see the flow of our role. Here we have tasks that main YAML that reads like a pipeline. 3 imports, 3 stages. We have validate role inputs. We have render intended configuration. We have deploy intended configuration. And notice the deploy stage is gated by a when condition on interface baseline enabled. That flag is worth pausing on. You can run the role with deploy disabled and get only validation and rendered files. In real-world projects, this usually means reviewers read the render output in a pull request day before any change window. Deployment becomes the last, smallest step, not the first. And the heart of that render stage is Jinja 2. We have our engine for Jinja 2 templates, our next section. Jinja 2 has exactly one job, and the formula on the slide states it. Intent data plus platform template equals rendered config. 4 facts to anchor when we are using the Jinja 2 templates. Templates render on the Ansible control node. Nothing touches the device during rendering. So rendering is always safe. Variables and facts are available during render. The output should be readable by network engineers. It is a config, not code. And the template logic should stay smaller than the config it produces, okay? If the template is more complex than the output, something has gone wrong. Rendering is free, but deploying is expensive. So we render early and often, and after that we deploy rarely and carefully. Because templates are code that pretends to be config, they deserve design rules. We must have design rules for our Jinja 2 templates. That is our next session. We have 6 rules, quickly. Keep input data vendor neutral where possible. Intent stays clean. Prefer small templates over giant branching files. Add white space controls carefully. On network configs, indentation is meaning. So you can't do this freely. Use clear variable names. Put platform differences at file boundaries when they grow. A separate ios.j2 file, a separate eos.j2 file, beats one template full of if Sesco, else Arista, okay? And always test rendered output before device apply. The theme is the same as playbooks. Reviewable beats clever every time. Rule number 5, platform differences at file boundaries needs a mechanism. Here is the selection pattern for the template that we are going to use in our projects. This is a task render.yaml file, 2 tasks that multi-vendor rendering elegant makes it great, okay? We have task 1 that selecting the platform template. We have set facts that build a small dictionary. Cisco iOS maps to ios.j2 file, and for example, Junos to Junos.j2 file, and indexes it with Ansible Network OS. Remember that variable from the inventory section, Ansible Network OS? This is where it pays off. After that, we have task 2, render the candidate configuration with Ansible built-in template into a rendered dictionary. one file per host. Ansible, one file per host. Inventory host name.csv, I mean. One data model in, one clean per platform config file out. No branching inside the templates themselves. So let's look inside one of those templates. For example, let's see the Cisco iOS. Here is the iOS.j2 file. And even if you have never written Jinja 2, you can read this. It is OK. A for loop over interfaces. For each one, the interface line with its name, then the description. If the interface has an IPv4 block defined, render the IP address line with address and mask. No IPv4 in the data. No IP line in the config. Then the enabled flag that is set to enable true renders no shutdown, for example, and enabled false renders shutdown. And if and for, you must close the loops, okay? Notice how the template mirrors the intent data structure one-to-one, okay? A reviewer can hold the YAML in one hand and this template in the other and predict the output exactly, which is precisely the point. And here what is actually comes out the other end. We have template output example. The render result, it is plain, it is boring and beautiful Cisco iOS configs. We have interface gigabit Ethernet 0/1. We have our description. We have our IP address with its mask. We have no shutdown, exactly what a network engineer would type by hand, which means any network engineer can review it with zero Ansible knowledge. And the workflow note, you must review the rendered config before apply. It is one cat command, okay, that you see at the bottom of the slide. That file is also a perfect artifact to attach to a pull request or a change ticket that you have. One more guard before we trust the render, okay? We rarely trust the rendered file. Check the data itself. So we need to pre-render data checks, okay? Templates render whatever you feed them. Duplicates included. So we check data before rendering. The assert verifies interface names are unique. Map the name attribute out of the interfaces list, apply the unique filter, and compares length. If the unique count differs from the total count, there is a duplicate. And we will fail with the message, for example, duplicate interface names found. The caption is the principle. You need to catch data errors before they come to the config mode, before they become config errors. A data error caught here costs seconds, but the same error caught on a device costs an accident. So what do we have here? We have data, we have playbooks, we have roles, we have templates. Now, the safety net around all of it. We need to have check, we need to have diff, we need to have drift. So let's see the compliance architecture. Compliance in this workflow is a 5-step principle, okay? We have it just like a pipeline. Read it left to right with me. Intended state, the data that we modeled before. The second part, the rendered config. That is what Jinja 2 produced. After that, we have device candidate diff. What would actually change on the box? After that, we have reviewer decision. A human reads that diff and only then apply or reject. The note at the bottom is the cultural shift. Compliance starts before the change window. By the time the window opens, everyone has already seen exactly what will change. The window itself becomes execution, not discovery. The first tool in that pipeline is check mode. Here we have our check mode, that is the dry run, -- check. Here with the production inventory and the limit to edge R1. What you get from the right side, it runs without making remote changes when the modules support it, which mainstream network resource modules do. It reports what would change. It is excellent for validating roles and playbooks against reality. And the honest caveat, some tasks need explicit check mode handling. For example, common tasks, for example, may need check mode setting of their own. Okay, check tells you that something would change, but diff shows you what. So after check, we need to diff mode. Same command, one more flag. We have dash dash check, we add dash dash diff at the end. Now you see before and after style output where the platform supports it. To practice notes from the right, use it against small targets set first. A diff for 200 devices is unreadable, and a security note, okay? Diff output can expose sensitive configuration of your company, where secrets may appear, send MP strings, key material, set diff to false on those tasks. Check plus diff together produce the single most valuable artifact of this whole workflow, a reviewable preview of the change. And that preview is only useful if we actually read it well. So let's see how to read a diff if we have it for example, 400 devices. Here is a real diff. This is so short. We have 4 lines, some minus, some plus. Small, but the second per brings an interface up. That is a real operational event, not a cosmetic edit, okay? So run the review checklist on the right every time. Does a diff match the ticket? Is this what the change request actually asked for? Is a target device correct? Are there unexpected removals? For example, lines disappearing that nobody asked to remove? And are secrets or tokens visible in the output? The key point here is a 2-minute diff review by the right person catches the class of errors that automation itself can never catch. That's security questions. Secrets in diff gets its own slice because it is where teams most often slip. We need to protect secrets in our review. When a task touches secret material, 2 attributes go on it. You can see both in the example. No log that is set to true and diff that is set to false. By using no log, you can keep values out of logs and job output. Diff false keeps them out of diff previews. The template here deploys a private config file. Its contents never appear anywhere. A reviewer, a log system, or a screenshot could leak them. At the bottom line extends this topic to AI topic. Use Vault or an external secret store. And never, ever, don't paste secrets into AI tools. Remember that sentence. It comes back in a few minutes for you. Check and diff cover planned changes. But what about the changes nobody planned? What is the solution and what is the strategy if we don't have any unplanned changes? That is drift. Drift is the gap between intended state and what is actually running. The hand edits the emergency fix at 3 a.m. The starter pattern is 2 tasks. Task 1, collect the running interface config. For example, Cisco iOS command runs show running config interface, per interface name, looping over our intent list, registered into a variable, and task 2 compares it to a intended state. Here simply printed with debug for a human to eyeball, okay? The caption is honest and important. Start simple, mature toward the structured parsing and tests. A weekly eyeball report already catches drift months before it bites, okay? Parsing and automated assertions can come later. Everything we have built, lint, inventory checks, render, check, and diffs chains together beautifully in CI, okay? Here, our CI review flow. This is the pipeline every pull request walks through. We have 6 steps. The PR opens. After that, we have YAML lint and Ansible lint check style and known bad patterns. After that, we have the inventory graph check that catches targeting mistakes. After that, we have our templates render. So the PR contains the actual configs. Check and diff run against the lab. And the final gate, step 6, is the human approval. Notice that machines do steps 2 through 5. and they never get tired or sloppy, okay? The human spends their attention only where judgment is genuinely needed. That is the division of labor we now extend to AI, which brings us to the part many of you came for, where AI fits and where it must not. So let's see the AI assisted review, where AI fits. Let me position AI in one sentence. AI here is review support, an assistant for humans, not a replacement for Gates. 5 places it genuinely earns its keep. Drafting task ideas from a clear intent, starting a skeleton in seconds, explaining existing playbooks or templates, priceless for onboarding. Finding missing variables or inconsistent names, that is pattern spotting, is what these models are good at. And also summarizing dry run diffs and drafting PR summarizes for human readers. And the warning at the bottom is non-negotiable. Don't use AI as the source of truth. Your netbox is truth. Your Notobot is truth. Your Git is the truth. The AI is a very fast, occasionally wrong colleague. Here is that positioning as a workflow diagram for our AI boundary. 5 steps, and the order is everything. Engineer intent comes first. You decide what should happen, okay? The AI drafts or explains. The engineer edits. You own every line the moment you touch it. Then Ansible lint, check, and diff. The same mechanical gates as always. And peer review as the last part. The bottom line that you see in the slide is the policy I recommend you adapt verbatim. Every AI output enters the same review path as human written code. No fast lane. No, the AI wrote it, so it must be fine, okay? The pipeline does not care who typed it. And that is exactly what makes AI safe to use. Let's make this concrete with 4 prompts I actually use. Prompt 1, that is for drafting. You can use in your projects. Read the prompt on the slide. Notice how much context it gives and how firmly it sets boundaries. You are helping draft Ansible network automation. Target platforms, for example, here Cisco iOS. We set the goal to configure interface description and administrate. We see that use roles where possible, don't include credentials, and return a small playbook skeleton and list your assumptions. That last line is the professional trick. List assumptions forces the model, the AI models, to expose its guesses. So you verify them instead of discovering them in production. The chips below name the 5 ingredients of every good prompt. You must have prompt, you must have the goal, data shape, and risk limits, and finally output format. Prompt 2 flips the direction. Instead of writing code, explaining it to me. That is, you can use in your Jinja 2 templates. You can paste the template and then this prompt. Explain it for a network engineer, focus on loops, conditionals, required variables, and rendered output. Flag places where missing variables could break the render. And crucially, don't rewrite it unless asked. Without the last line, models love to improve code you only want to explain, okay? As the tip says, use this for onboarding new engineers and as a pre-read in peer review. After these 2 prompts, we have prompt 3, that is for reviewing inventory data with band precaution, okay? We have review inventory data. The prompt review the sanitized Ansible inventory hosts output. You can find inconsistent platform names, missing connection vars, site naming mismatches, and host-specific values that should move to group vars. Don't infer real topology, okay? Return findings as a review checklist. The word doing the heavy lifting is sanitized, and the tip below spells it out. Sanitize host names, IPs, credentials, and customer details first. The AI reviews the shape of your data, never the secrets inside it. And prompt 4, my personal favorite, summarizing dry run diffs. Here we can see that. We use it for summarize this Ansible check diff output, group changes by devices, mark high-risk changes, for example, shutdown, no shutdown, ACLs, routing, AAA, SNMP community, management access, default route, and the boundary line again. Don't approve or reject the change. The AI writes the executive summary. The human makes the decision. This is the main part. As the tip says, the summary helps reviewers scan. The raw diff remains the source. On a 40-device change window, this one prompt saves reviewers 20 minutes and focuses them on the 5 lines that matter. We have 4 prompts, 1 discipline. Now the guardrails that keep all of this safe. We must to have our AI risk controls when using it. We have 7 controls. Don't forget to screenshot this slide. It is your team's AI policy starter. Never send secrets, tokens, private IP plans, or customer data to AI tools. Use standardized examples, ask for assumptions and uncertainty in every prompt. Require source control changes. AI output goes through Git or it does not go anywhere. Run lint, check, and diff on everything. You need to keep human approval before apply and log AI-assisted review decisions in the PR. Future engineers deserve to know how a decision was made. None of this is exotic. Together, they let you say yes to AI without saying goodbye to control. And when the AI hands you output, run it through this 5-question checklist. 5 question, 5 reason. Read the table with me. Did it invent modules or parameters? Models hallucinate plausible-looking module names. This prevents invalid YAML file. Did it hide assumptions? Surfaces risk. Did it change scope, touching hosts or sections you never asked about? Protects the blast radius by using this part. Or did it expose secrets? By using this, you protect the data. And did check and diff pass? Validates actual behavior, not claimed behavior. 30 seconds per review, and it catches essentially every AI failure mode that matters in practice. That completes the method. Let's land it in day-to-day reality adoption. That is your demo storyboard. This storyboard is the whole webinar as a 7-step exercises. You can replay at your desk tomorrow. Show the project tree, validate the inventory graph, open an interface data, render platform-specific config, and the other parts that you can use. Of course, real adoption also means knowing what actually or usually goes wrong. So let me save you some bruises. 7 failure modes I keep meeting in the field. For example, you have inventory targets, the wrong group. Variables duplicated across host and group files. 2 sources of truth that you have in your Ansible, forever fighting. Diffs that include sensitive output, teams applying before review is complete, usually under time pressure. It is so important. Platform names that don't match collection expectations, for example, iOS versus Cisco iOS.iOS, okay? Template branches hiding vendor-specific behavior, and an AI summary missing a risky line. Here is the reassuring part. Every single one is prevented by something we covered today. This slide is really a checklist of reasons to adapt the previous 50. So what does the healthy day-to-day team practice looks like? Here is the full loop. It is a loop, not a line. Every apply teaches the next intent, and notice where AI sits. Step 5 of 9, a helper in the middle. Never the door at the end. You do not adapt all 9 steps in one day. You grow into them by stages. Here, you can see that from lab scripts to workflow, we have 5 maturity stages, one on a stable. The stage lab, the pilot part, team part, production, and mature part, okay? And to make the first move concrete, here is the 30-day plan for you. 1 month, 4 weeks, 2 actions per week, deliberately modest. in which one you can move inventory and variables into a clear tree and add Ansible inventory graph checks. In week 2, you can extract one repeatable workflow into a role and add template rendering before apply. And week 3, you can add check and diff review steps and protect secrets during diffs. And in week 4, add AI-assisted explanations for sanitized diffs and document the review workflow. Foundations first, assistance after. Follow this plan, and in 30 days, you will have traveled to full rows up that maturity table. Let me compress the entire hour into one line, can pin above your desk. Here it is, the final model, and the whole webinar as an equation. Good data plus small playbook plus reusable roles plus readable templates plus check and diff plus source control plus careful AI review equals safer network automation projects. Okay, 7 terms, not one of them is exotic, expensive, or beyond your team. And notice the sum is not more automation or faster automation. It is safer automation. Speed is what you get for free once safety makes trust possible. That is the message I hope you take home tonight. Everything I showed you stands on official documentation, and also you can have the sources in the next slide. And thank you all for attention to me. I switched the presentation to say it.
So thank you, Ehsan. That was a lot in 1 hour. Actually, I'd love to talk about one interesting thing that might help, absolutely help a student that wants to be part of this journey. It means that we are not just selling a course, like, for example, okay, just register and study by, for example, this book, or, for example, practice by this labs. No, we are going to give you a real interesting thing, which means that we are giving you a package of a couple of things together. What does it mean that, people? Actually, it means that instead of just having a course with us, regardless, you are going to actually level up yourself, find a better job, level up your job, or even actually clear the certificate. We are here to help you around the course. Means that you have your mentor, you have your dedicated mentor. We'll help you to, for example, find a job in LinkedIn, whenever you are, doesn't matter. We have a great marketing team that help you all the time. We'll help you to, for example, make your resume better around actually the course that you actually study with our actually instructor, and a lot of things that might be interesting for you, actually, unlike the other competitor. So first of all, I want to talk about 2 paths forward that we have. Actually, the first one is CCIE automation, and the other one is going to be CCIE automation. Absolutely. Can you hear me? It's fine. Any question? Okay, the first one is going to be CCIE automation. Absolutely, you see the price that might surprise you. It's early bird, just $299. And for the CCIE automation, who is going to be for the person that's have already experienced about CCIE automation, and it's going to be just $1,049. So let's talk about CCIE automation. If you don't mind, Ehsan, go to the next part. The first is CCIE automation, as I said. It's going to be for you that already know about networking at the CCNA level. I'm not talking about CCNA automation, the CCNA level of Cisco. That's actually, we already call it CCNA version 2 or version 1.1, doesn't matter, it's fine. So if you want to add your, for example, add the skill like Python, API, automation, and even be prepared for actually 20901 exam, it's going to be for you. Last year, Cisco renamed actually the course to CCNA automation, and from now on, we just call it CCNA automation instead of DevOps. Ehsan, if you don't mind, go to the next part. Thank you. So On the career side, this is the rule that exists and pays. It means that network automation engineer, DevOps engineer, DevOps network engineer, Python network engineer, these are real job title people. Actually, companies hire for now, and you just by learning and studying CCNA automation, absolutely you are going to be headhunted by recruiter. So entry salary is, it's actually it's depend on the country that you are. It's going to be, if we just focus on the US market, it's going to be behind 89K per year, or as a mid carrier, it's going to be even 120K yearly actually. So Esan, please go to the next part. So as you see, the curriculum is here. For example, how many percentage for infrastructure automation, REST API, software development, Cisco platform, app deployment and security, and network fundamental. But along with this one, which is actually curriculum from Cisco, we are going to add AI part as well to make sure we are actually adapt to the current market. It means that you learn a lot about AI, how to use AI, how to actually deal with AI to make your job easier and even grow fast by, for example, going fast by AI on your job. Go to the next part. And what else? As I said, we have one-to-one membership, live instruction, recorded and lifetime access, and career support that help you to, for example, grow up your LinkedIn, resume review, mock interview, anything. We are here to help you. We are here to be with you to level up yourself. So just you need to join. You don't need to pay anything for now. As I said, the price is going to be very low in the market. It doesn't mean that we are going to actually decrease the quality. It means that we just wanted to be with you. We just wanted to help you to level up yourself and clear your exam if you want. So the part that I love to have actually is going to be the CCIE automation training. And as you see here, it's going to be 16 plus week. By the way, we are not going with bootcamp, even for CCNA or CCA. It means that unlike the other competitor, we are not holding the entire entire course in 1 week or 2 weeks. We think and we believe that we should be in a long-term, for example, let's say, part for example, scheduling, for actually having the knowledge of CCA automation or CCNA automation. Nobody actually study CCNA or CCA automation just in 1 week or 2 weeks. So you have to practice, you have to actually study, you have to break things, you have to fix things in 16 weeks, even more than 16 weeks, to make sure everything actually for you is become easy after each week. So if you don't mind, Hassan, go to the next slide. So as you see, actually, the second course is going to be for senior engineer in this room, CCIE automation. This is the top of Cisco automation ladder. Actually, it was DevOps, DevNet expert. So nowadays, Cisco call it actually CCIE automation. As I said, it's going to be 16 plus weeks. And 2 or 3, for example, or let's say 2 live sessions a week that help you to grow up yourself. So here's the curriculum. Actually, here's the percentage of each. Like, for example, in infrastructure as a code, it's going to be 30%, network programmability, software design, development, and deployment, security, container and cloud, as well as AI that we wanted to add it here to make sure you are ready for the market. If you want to just, for example, get your exam, be prepared for exam and clear the exam, absolutely the AI part is going to be a bonus for you. if you are going to be, let's say, CCIE level of in the market, to make sure everything actually for you become easy once you want to start automation for any company, AI is going to be the best part for every person that's want to actually make everything like automation. So at the end of the day, we have actually price for this one. If you want to become a CCI automation, you just need to pay around $1,000. Just please join now. And if you have any question here, we are here to actually answer any question that you have. Feel free to ask questions.
Dear Shade, we have a question that Brian asks, is this going to be on YouTube? They want to know that how they access the slides and the video.
Yeah, absolutely. We'll actually upload it to YouTube as well.
Any plan for CCNP automation training? This part, we are focusing on CCNA and CCIE automation. And after that, we'll go through the CCNP automation with the specialty parts tracks.
It's going to be next 3 weeks, something like that, Ehsan, for the webinar that we have for that, right? So I hope you have a great day, great time, and everything goes well for you. If you don't have any question, feel free to leave, and have a great day. Bye-bye.
Thanks a lot for joining us. Good night, everyone.